Alright, let's talk about some sets of numbers. So we have our basic sets of numbers that we can talk about. We have a few here. Integers are all positive and negative whole numbers. This includes the number 0. Then we have rational numbers. Now rational numbers can be integers, so they can be positive and negative whole numbers like we have up above. So like negative 5 is an integer, 0 is an integer, 3 is an integer. Fractions are rational numbers because rational numbers really are anything that can be written as a ratio or a fraction of two numbers. So for example, 5/3 is a rational number. This includes mixed numbers like 1 and 2/3. It's also a rational number. Terminating decimals. Now terminating means to stop. So these are decimals like this example here, 3.25. It stops at 5. So it'd be if you calculate something in your calculator and it goes to 2 decimal places and stops, or 3 decimal places and stops. It doesn't go on through the end of your calculator. The other thing that's considered a rational number is repeating decimals. This is decimals that repeat the number over and over again. For example, 2.33333. We a lot of times will write that as 2.3 with a line over the top of the 3. Now this can be any type of repeating number. So for example, 1.67, 67, 67, since it's repeating the 6 and the 7, that would be considered repeating. These are all different ways that rational numbers can be written. Irrational numbers are our final type. Now, irrational numbers are all decimals that do not terminate or repeat. So, for example, if you were to get from your calculator 2.456732, notice nothing's repeating there. They're all random numbers. And the ... indicate that it continues to go in your calculator. An example of this, and a lot of times these you have to determine using a calculator. So for example, the square root of 2. If you were to put that number into a calculator and get your answer, square root 2, you get 1.414. Sorry, let me find my spot. So for example, you'd get 1.414213,562, and it continues onward out the end of my calculator. This is an irrational number. It's a decimal that does not repeat and it doesn't stop. Alright, next let's talk about ordering numbers. Okay, so we have different types of numbers. Let's talk about how to put them in order. The fastest way when you have just a random set of numbers is to put them all in the same form, and the easiest form to compare them in is as a decimal. So you would use your calculator for this. For example, you would put square root 10 into your calculator and then write down that decimal so that you can compare them. Now when you do that, you get 3.16227766, and it goes on from there. This would be an irrational number. Okay, 1 2/3. Now if you're wanting to change a fraction to a decimal, what you do is you take the top divided by the bottom. So that's exactly what you would do, is you'd do 2 divided by 3, which gives you 0.66666, a repeating. But notice we have that 1 in the front, so it's 1.66666 continued. Okay, 2 square root 2. Again, you would just use your calculator for this. You would do 2 times the square root of 2. Now some calculators make you put that symbol first, some second, so just try it out with your calculator, see what you need to do for yours. To test that, you should end up with 2.82842, and it goes on from there. Look, another irrational. So we have a rational number, or excuse me, an irrational number. Then we had a rational because it's repeating. We have an irrational number here. 1.1 with a line. Remember, that means that the 1 is repeated over and over. That is also rational, repeating the rational. And finally, we have the symbol pi, which should be a button on your calculator. Again, try that out. use the pi button on your calculator and see what number you get. Okay, and you should get it. It's approximately 3.14, but notice that number continues. 15926 goes on from there, telling us this is irrational. But what we're trying to do is put them in order from least to greatest. So we put them all in decimal form, so we could look at them all on the same scale, and now put them in order. Which of these is smallest? Well, the 1.1, so that would be first, so I'm going to match it up there. The next one would be the 1.6, so that's our second number, so I will match it up with 2, the second number in order. What comes next? Well, next we have 2 and 2 threes. The 2.828 would come next, so that's our third number. Then what we have a 3.14 down here and a 3.16. 3.14 is smaller than 3.16, so it would be fourth, and finally the 3.16. So again, if you're putting in order, the easiest way is to take a calculator, put them all in decimal form, and go on from there. Alright, let's classify some of these numbers. Now, R means real. So far, all of the numbers we deal with now are going to be real numbers. This is kind of weird, but Q is for rational numbers. That's something you'll just want to have in your notes because it's kind of hard to remember that. Z means it's an integer. Again, doesn't have the same first letter, so that's something you'll want to have in your notes. And then we have irrational, which sometimes people abbreviate with an I. So let's look at the number 5. Well, it's a real number. Is it rational or irrational? Well, let's see. It's an integer. Remember, integers were those positive and negative whole numbers. So it goes in the Z group. And then we have, is it rational or irrational? Now remember, rational numbers are all whole numbers, which this is, and decimals that stop, and decimals that repeat, and fractions. So this is a real number. It's also an integer and a rational number. Negative 0.359 is a real number, and I don't even know if they'll have you say real for now, but okay, next, is it rational? Remember, rational numbers are all fractions, whole numbers, decimals that repeat, and decimals that stop. Notice this decimal stops. There's no dot, dot, dot at the end, so we know it's stopping. So it goes as a rational number, or the Q group. Is it an integer? No. Integers have to be whole numbers, positive and negative whole numbers, and this has a decimal. Is it irrational? No. If it's rational, it cannot be irrational. And finally, we have the number pi. Again, the best thing to do with pi or square roots to determine if they're rational or irrational is just put them in your calculator, see what decimal they are, because we know that if the decimal stops or repeats, it's rational. So see how this one just keeps going. It stops in my calculator. That's because my calculator ran out of numbers. It's not because it's a stop terminating decimal. So this, while it is a real number, okay, it is irrational. Okay, so that means it cannot be rational and it cannot be an integer. Alright, now let's talk about inverses. Inverse means the opposite of something. We have two types. We have additive inverse and multiplicative inverse. Additive inverse, when you're finding that of a number, if it's positive, its inverse is the same number, just negative. So for example, if we have the number 3, its additive inverse would be negative 3. If we had the number 2, its additive inverse would be negative 2. Okay, pretty straightforward on the additive. It's what you would add to it to make it equal 0. Multiplicative is the opposite also, but it's the opposite as far as reciprocals. And maybe you remember the word reciprocal from doing fractions. Reciprocal means you flip a fraction. So for example, the multiplicative inverse of 3 over 2 would be we flip that fraction and get 2 over 3. Now with multiplicative inverses, you're trying to find what you would multiply it by to get the neutral of 1, which 3 times 2 would be 6 on top, 6 on bottom, or 1. The multiplicative inverse of 1/2, we flip that over, would be 2 over 1, which we typically write as 2. If it's a negative, like negative 3/2, its multiplicative inverse would have the same sign, just flip this fraction, negative 2/3. Okay? So let's take a look at some examples here. Oops. Okay, so here we go. We want the additive and multiplicative inverses of each of these. Remember, additive inverse, you just write the same number with the opposite sign. So the additive inverse for this would be negative 3/5. Multiplicative is where you flip the fraction. The multiplicative inverse of 3/5 would be 5/3. So for additive, you change the sign. For multiplicative, you leave the sign the same, but flip it. How about negative 0.025? Well, additive is easy. We just change it from negative to positive. So its additive inverse would be positive 0.025. Multiplicative, you're supposed to flip it. Well, this isn't a fraction. But what we do if that's not the case is we write it over 1. Because technically this is this over 1. So we flip that. And we have 1 over 0.025. But that doesn't make much sense. So what you want to do is put that in your calculator and find out what the decimal is for that. So what is 1 divided by 0.025? So when you have a decimal and you're trying to find the multiplicative inverse, take 1 divided by the number and that will give it to you. And it was a negative originally, so our multiplicative inverse will also be negative. So its multiplicative inverse is negative 40. Again, you do that when you have decimals. You do that by taking the number 1 divided by the number will give you its multiplicative inverse. Finally, 12. Well, additive inverse, you just change the sign. That would be negative 12. Multiplicative inverse, you put it over 1 over the number because we're flipping it, and if it doesn't have a bottom, you assume it's 1. To find the decimal for that, you divide 1 divided by 12 is 0.08333. It continues from there. Right, so there are 3 examples of finding multiplicative and additive inverses.